to add project.
Sufficiently audible.
I can hear you.
All right, good enough. So I don't have a slide that's sort of an about me thing, but after the previous talk, I think it's a good place to start actually, because by training, I'm an electronic structure theorist. So all of the work on the CI related to the NWChemEx project was kind of a necessary evil that somebody had to deal with, and I didn't duck. So just want to make that clear, I coming at this less of a point of view from maybe a solid software development background. Also, so some of the, I didn't know what the order was going to be here. So some of this is probably going to be sort of backing up a little bit more fundamental to start with, and then moving on to more specific stuff. I think we're also going to see some pieces that are pretty similar, which makes sense. So anyway, with that said, I'm going to be talking about how we're currently handling the CI/CD issues inside the NWChemEx stack. So for those who maybe don't know, NWChemEx is one of the projects that was funded under the Exascale Computing project. It's intended to be the successor for the previous NWChem, which was a monolithic package primarily written in Fortran, and we wanted to, the impetus for this project, well, there were several different components, but one of the things is just a more modern rewrite of the fundamental pieces using a combination of C++ and Python with a focus on modularity, which I'll talk a little bit more about in just a moment. So this was aimed at the new generation of exascale supercomputers, but it's also designed in such a way as that we intend it to be hopefully used by other machines, not just leadership supercomputers. And to facilitate part of that, we utilize this plugin system pretty heavily, which is a whole other talk. But the key component here is that the NWChemEx stack is very segmented. It's very modular, to reuse the word, so this is a really simplified ecosystem sort of drawing. So, and it's very simplified in the sense that the central sort of pinkish box that says internally developed plugins would be a lot of different boxes that mostly represent different electronic structure methods that you could apply. So for those who are familiar, you would have, say, mod plugins to handle an SCF calculation, to handle an MP2 calculation, to handle a couple cluster calculations, DFT calculations, on and on. And you could have multiple of those because they could be developed differently. So everything inside of the central blue box is the sort of like canonical NWChemEx stack. These are the things that we who identify ourselves as being part of that project maintain and control and intend to be interoperable with each other. And all of these things we basically require should be able to reuse the CI stuff that we're going to talk about in a minute. But each one of these is a separate repo on GitHub. And so there becomes questions of how to sync that and maximally reuse things and minimally repeat things, so on. So the yellow box here denotes plugins that, through utilization of this SIMD, which is the simulation development environment, sort of the jumping off point in our stack for anybody who wants to start writing some sort of module that does something in the chemical space. Usually method calculation is kind of the idea. But if you yourself wanted to write your own implementation of SCF using whatever cool or interesting technology you have, you would start from the SIMD box, and then you would probably be one of these yellow boxes of externally developed plugins. And so part of that is, with regards to the CI, is we want whatever we've designed to also be usable by those people, so as to lower the barrier to entry for them to be able to contribute and extend and use our components. So that's I didn't say this before, feel free to interrupt. But with this being said, that's our reasoning for why we need sort of this decentralized, or sorry, delocalized, no, centralized, there we go, sorry, CI setup. So this is the part that's going to get a little bit basic because we kind of jumped into the CI stuff. Now I'm backing up a little bit to what is CI and CD. I can probably go over this pretty quickly. The basic idea, right, is that you're closing the loop between sort of development and application or usage of an application. So if you search CI/CD and you read any number of blogs, you will see probably a dozen different variations on this image I have on the right. I just picked the one that I thought had the pieces in the most reasonable places. To a lot of people, I think CI/CD means automation, which is definitely a key component to the way that it's done. It's not the singular definition of it, but it is pretty heavily associated with the automation of building and testing and deploying code in a continuous fashion, so that somebody raises an issue with your current version of your code, you come up with some way to fix it, you code that up, and then it's built, it's tested, and as soon as it passes tests, it's released, and everybody has access to the fix. It's also useful for enforcing different quality controls that you want to have on your code bases, making sure people are keeping with style guides, making sure they're not introducing warnings or whatever into your build system. Theoretically, so this last point kind of doubles back to my leading statement about my role in this. So in theory, another useful aspect of sort of putting together the CI/CD stuff is that a lot of these cases for science-related code, I feel like it's usually tends to be smaller teams. And so theoretically, if you've got a good CI/CD system in place, you can kind of take up some of the slack of people having to build and test the code that other people are putting together. But that's in theory, because the problem is, right, this is never just that easy. Everybody's had that experience where they think to themselves, oh, I have to do this all the time, I should just automate it. And then you start trying to write something to automate it, and it becomes more complicated than even like the original problem that you were trying to solve was. So there's so many different tools that you can use to try to solve this, and every one of them is going to say that they're the best for whatever reason or another. So, and then, yeah, like I said, you're always going, my primary role is to implement and develop electronic structure theory, but we need this stuff to not break, and so somebody has to do that, and that's me. So with that in mind, the first kind of major point is that, yeah, there's so many different options for this stuff. We just heard about using GitLab for this. I'm going to end up talking quite a bit about GitHub Actions. There's so many others. I just picked a few others, but these are just the top ones. There's an endless list. And then down on the bottom here, we've got a couple of options related to containerization, which I'll talk about a little bit more. They're not necessarily CI tools in and of themselves, but they have heavy usage in CI potentially. So yeah, the best thing I can say on this one is that to a certain point, you just have to pick whichever one seems the most useful for you and which one makes the most sense in your brain and just kind of run with it. And in our case, that's going to be GitHub Actions. But so our concerns with regards to our project in particular, like I say, we got different repos on GitHub for each one of these different sort of components, and we don't want to have to maintain individual CI/CD pipelines for each one. And so there's a couple of different ways to handle that. You can try syncing files, which in the past, when we've done that, has always turned into a mess very quickly. So I'll talk about how we handle that currently. We get operating system differences. As somebody who spends a lot of time developing on a Mac, it's not the same. You're going to find every possible edge case that you can. So we're a C++ project, and we have a bunch of dependencies that are C++ that have to be built from source, and those build times take time as well. So we want to be able to cut down on that in some meaningful way. Dealing with multiple programming languages, dealing with constantly evolving list of tools to play into every different problem that we have to deal with. So how do we currently handle sort of the key points of all of this? The first one is, like I just mentioned, containerization. This handles several of those points from the last slide. This is how we're handling basically caching dependencies and ensuring a repeatable, reproducible environment for each of the tests. And yeah, Docker is the most common version of this. Docker is fairly synonymous with containers, but I think containers don't necessarily mean Docker. There are other options, but that is what we use. So this allows us to have a reproducible environment that we know what circumstances the tests are going to be run in, and if they fail, it's easy enough to replicate the environment, repeat the test, troubleshoot, debug, whatever. And it also serves as a pretty useful starting place for a development environment for individuals who are trying to work on additions and stuff like that. The other main thing that we use at the moment for syncing the procedures across the different repos is GitHub's options for reusable workflows, which sounds very similar to, I believe they were sub pipelines, or I believe was the term used in the previous talk, referring to the GitLab ones. Basically, the key thing here is that you're able to write the procedure one time and then have that reference that procedure in a different repository so that you don't have to fully rewrite it. And if you make changes in the central location, they propagate throughout everything that uses it. It's also extensible because you reference the central workflow inside of a local workflow, which you can then add additional components to. So that way, every repo is a little bit different, so you can change stuff up a little bit. And then, so yeah, what remains is basically just like a super quick tutorial on how that works in GitHub Actions. Like I said, there's got to be options like this. I think we just heard about one for GitLab that's similar. So as a couple of example cases, these are super toned down versions of the centralized workflows that we use to handle our pull requests, and then the next one will be the merge procedure. So in this case, like I say, C++, so we're taking in a list of compilers and the version of the documentation that needs to be built. And we just define a procedure for how that looks like. And you can see here, GitHub Actions supports using containers directly. So we just tell it the image of the image that we want to use, which is our build environment one, and then it proceeds to run everything inside of that. And then yeah, this would be, and unfortunately is considerably more complicated in the actual versions, but this is the general idea. Similarly with the merge workflow, simple version bumping, and then automated deploying of our documentation, which is largely auto-generated through this process. And then, so the way this looks inside of each one of the individual repos is just sort of this. So for a pull request, you would just specify which compiler versions you're currently worried with and what the name of the document target would be, and then it's going to run that test automatically. And then for the merge case, similar thing, but say you have an additional step that needs to be run on merge, you can add that here very simply, and then it'll do the common sort of required components, and then do the additional parts here as well. There's a bunch of other. So workflows is one way to do this. GitHub also has actions in and of themselves, which several of these things could probably be compartmentalized into actions as well. But anyway, that's basically the crux of it. So at that point, we can open up to questions and hand control back to Ryan.
Thanks for that talk. As Jonathan said, any questions?
I'm kind of curious on the N-2 slides from here. So you had, yeah, if you go back 2 slides, and maybe even one more. Basically, there was a part where you said, yeah, here it is, build library and run tests here on the right, line 34. It's like, oh yeah, this is a mess, so I'm hiding a lot of stuff. And then
yeah,
in the next slide, you're like, okay, cool, but we already put that big mess in this other repo, and so we're just, or maybe it's one more ahead. It's basically wherever you're, yeah, here line 12.
Yeah.
You're like, okay, I'm just grabbing all the gobbledygook from that other repo from this branch. If you're making a change to this repo that requires a change in those build steps, do you have to go to the workflow repo and make a separate version of the workflow that has the commensurate changes in the build steps?
Something like that, yes. So when I say these are super toned down, there's a decent amount of switches that are pulled out of these like inputs. That it depends on how sort of, and there's not like an explicit rule for this in any sense, but it depends on how common enough the problem is going to be, I think, in our case, as to whether or not it's easy enough to just throw like a switch on here that says like do X or don't do X. Whereas if it's truly unique to the repo in specific here, each one of these steps, the way that they're actually coded up in our case, they're fully optional. Actually, it's even included here. So you just got the simple conditional that says if it's empty, don't do it. So if whatever the test library case is here isn't sufficient for the specific library, you can just turn this off, use whatever components of it are actually relevant, and then you would have like you could extend this with the more specific version of whatever that repo needs. Does that make sense?
Yeah, that does. Thank you.
Yeah.
Yes, I had a question about containerization. For you, it's a solution here to many problems, and I guess my question is are containers used in production for your code? For us, they're not. So containerization wasn't a solution because I would say, yes, we are not, users are not using containers there, and now they're using Spec to describe the dependencies. So it makes sense for us to use Spec in the CI. So it's a different choice, and it's also forced us to choose. I mean, it's also helped, I don't know how to put this, but the choice of GitLab was more straightforward. We invested in GitLab through an ECP project, I think, to develop the runners, the specific runners that run on clusters, HPC clusters, instead of using containers. Normally on GitLab, out of the box, you would use containers, I would say. Here we run on the machines with specific runners. So it's a completely different solution. That's what I wanted to emphasize. But my question is, yeah, are you using containers in production in that case? Fine.
Not really, no. In our case, honestly, it's I think it is a solution to we don't have like dedicated runners for this stuff anymore, and so it's just a way of replicating of ensuring a reproducible environment for the CI setup. Because you could honestly, yeah, you could probably replace the containerization if you just have like a dedicated machine, a self-hosted runner or somewhere that already has the stuff that you want installed on it. To be honest, the GitHub runners themselves have quite a lot of stuff already pre-installed on them. So some of that is maybe, I won't say overkill. There's other solutions that we just didn't have available to us at the time. And also, it does make it easier in the sense, again, of it's a like half put together development environment of sorts. Because like I said before, like I primarily work on my Mac, which sometimes behaves differently than the Linux machines that the vast majority of the stuff is actually going to run on. So it has a few different uses, but there's definitely other options that may be simpler or even more effective. It's just what we're using for the time being.
Yeah, and I see in the chat that Eric Palmer is saying that as far as he knows, NChem users at NERSC are using the NWChem containers, and that was kind of my underlying questions. When you use containers in your CI, your containers becomes valuable because in some sense, because since your tests are based on containers, then it means if you take the containers, you're guaranteed to get something that's working. It seems to me, and if you end up deploying containers, for example, you guarantee the user that they will be able to run something that has been tested. So it's interesting because I think it's interesting to consider.
Yeah, I think the easiest answer is that currently we just don't sort of deploy in a container, but there's really nothing stopping us from, I don't think. It's just, again, it's not to belabor at this point. This is one thing that I have to do. So there's multiple. I haven't solved necessarily every issue that we've come up with so far. We literally have a wish list of things that needs to go into the CI. So, but yeah, no, deploying it as a container is definitely a useful option in some cases.
Can you give some examples of some of the crazy stuff that each of the individual projects demands you support? Like, what makes each project a snowflake? Why do you have to go to the extent of including
The
it?
vast majority of ours are not actually. I don't know if maybe I made it seem that way. A lot of our stuff is actually pretty straight, where it's very similar in their individual steps. Like the number of inputs is maybe I should. The number of inputs seems like a lot to me at times, but maybe not in the sense of if you've ever gone and looked at the YAML files for like some of the GitHub actions and stuff out there. But it's mostly just cases of honestly trying to do maybe too much at one time is even part of the thing. But no, a lot of our repos are fairly straightforward. Probably the most unique one is one called ChemCache, which has an additional step where it has to generate after changes have been merged into master, it auto generates a different branch that has to have a lot of sort of generated files pulled from outside reference sources. But no, actually, a lot of our stuff is actually pretty similar. Yeah.
Maybe I missed it, but how is it pulling down the source code for each of the projects that it's building?
Oh, these lines like 31 and 44. In terms of like GitHub actions, see that the checkout action pulls the source for the current thing. If you're talking about like for dependencies and stuff like that, our projects are built with CMake, and specifically we use an additional library for that called CMaze, which Ryan can talk about quite a bit more than I can because he's the author.
Gotcha. Thanks.